So this is what we would expect.
Yeah, well, first, thanks for having me on, Joe. I really like being on your show with you and Becky, Andrew, Kramer, and especially Meg Terrell. You guys have realized that if we're going to inform the public, we have to have it based in science. And we can't have wild speculations out there. We really have to focus on what we know and what we can know and get to real data. So far, Omicron looks like it is of great concern. One has to step back and think about, how did we get this Omicron? It didn't just slowly mutate, it looks like. To me and to many other scientists, it looks like this is a case where it evolved in a single immunocompromised individual. Because if you look at that paper, actually, you're referring to in the New England Journal, right, it explains how that can happen.
152 days the patient had it. And that was the point I was going to make, Len, is that we seem to think that if COVID is multiplying in all these unvaccinated people, that you're going to get these random mutations. What this says to me is that you put it in one single incubator of an immunocompromised person, and you get multiple variations in that person because the immune system doesn't get rid of the virus. So 156 days, it happens in one person, which makes me think, Len, we need to treat immunocompromised people with antibodies to get rid of it. It won't help as much just to vaccinate. If the variants aren't coming from unvaccinated people, but immunocompromised people, we need therapeutics to make sure that we don't let something fester for 156 days.
Joe, you're spot on. We have to deal. Some people like to say this is man against virus, but in some respects, it's mankind against virus. We're all sort of one organism. And if we have a weak link in the chain, because some people, unfortunately, are having chemotherapy, or you know that in the Gauteng province in South Africa, the incidence of HIV infection is about 20%. So it's not a surprise that in that immunocompromised population, that variants are emerging, and they're emerging by leapfrog kind of mutation, not slow evolution. And this is going to keep going until we deal with treating everybody, including the immunocompromised. We have 5 to 10 million immunocompromised people in the United States. And we have to deal with that population, or we'll have the same problem here. It won't be Omicron, it'll be the next letter in the Greek alphabet.
So we need to, that's why I said we could be immunizing and vaccinating people, but immunocompromised people, they don't have the immune system to respond to it. So we need to ramp up efforts for therapeutics. So how quickly can you or Lilly or somebody else customize a monoclonal antibody to a variant? How quickly can we get that rolling?
Well, so we've been having it rolling for a couple of years now. Remember, we designed our cocktail and tried to anticipate the changes. We anticipated the changes that Delta would give, and our cocktail was very effective against Delta. You should remind your viewers, we should all remind our viewers, that the monoclonal antibodies that are out there now and are authorized for their indications for the virus that's circulating in the U.S. works just fine. So we shouldn't abandon that. But we have to anticipate the next one. And Omicron is a difficult one to anticipate. We've actually thought about a lot of even most of the variations that could occur in Omicron. And we have another antibody that looks promising that's already started clinical testing. But we have probably the largest collection of antibodies in the world. We think we're going to be in this for a long, long time. Just like vaccines are going to have to adapt, we're probably going to constantly have to adapt our monoclonals, and we have a large repertoire of them, and that we're going to have to keep cycling them, Joe.